Good morning, my calculus friends. What do we have today? Today we are reviewing for your test tomorrow over basically the second fundamental theorem of calculus. Right? That's talking about the derivative of an integral. D dx of an integral from 0 to x of some function. Okay? And what we find is when we take the derivative of the integral, the answer is just f of x. Okay? When we take the derivative of the integral. Now, if this x is a function like 2x or x squared or half of x or anything other than just x, we have to multiply by that derivative, right? It's a chain rule derivative for our integral. Okay, now if it is just x, then of course this is a times 1, and that doesn't affect your thing at all. Okay, but if this is sine, or if this is e to the x, or any other function other than x, remember to multiply whatever function is here times the derivative of that thing. Okay, just so we know. All right, so here's a classic AP question. We have given a graph. These are a bunch of lines. Says it's continuous on the closed interval from -4 to 6, right? Continuous means a couple of things. And g, capital G, is a function defined by this integral from 0 to x of f of t. Okay, now on what intervals is the graph of g concave up? Okay, this is basically a conceptual understanding problem. Okay, g is concave up when the second derivative of g is positive, right? That's our conceptual understanding. Functions are concave up when their second derivative is positive. So let's look at what we have. We have g is the integral of f. Okay, so then what is g prime? Right, g prime is the derivative of an integral. So g prime is f of x. Right, and that's what our second fundamental theorem says up here. If we're taking the derivative of an integral from 0 to x, or from a to x, the derivative of that integral is the function evaluated at x. So this is our fundamental theorem number 2. Therefore, g double prime is equal to f prime. Right? This is the calculus conceptual understanding. Right? All of this stuff. Right, because notice we haven't done any quote-unquote math yet. We've only been talking about the concepts. So now we're here. What does f prime of x stand for? This stands for the slopes. The slopes of your lines on f, right, of f. So, where are our slopes for f positive? Well, this is a positive slope, right, because it's going up. And this is a positive slope. So, g is concave up. So, we would write this, right, if this were an FRQ for real, this is what we would write. So, this is the complete sentence. We're talking about the graph of g being concave up on these intervals, right? This is your answer. But we have to write the entire thing, use complete sentences, -4 to -2, and then again from 2 to 6. Okay, and then we're going to link. We want the graph of g. We link it to the picture that we're given of f, and it's got to be positive on those intervals. Okay, so that's the complete answer for part A. Okay, here's part B. Part B says now there's some other function p. There we're defining some other random function, which is g of x, right? This thing, times f of x, which is basically the graph, right? F of x is the graph. This is the graph of f right there. And it says find p prime at 3. So p is defined as the product of two functions. So how are we going to take the derivative if we have the product of two functions? That would be the product rule. Okay, so hopefully you remember the product rule from way back in the first semester. The product rule says we take the derivative of one of them, multiply it by the regular, right? So g prime times f plus g times f prime. Okay, that is our product rule for calculus. The derivative of one times the function plus the function times the derivative of the other, right? That's our product rule. So now we want to find out what p prime at 3 is. So that's g prime at 3 times f of 3 plus g of 3 times f prime at 3. Okay, so now we're going to have to evaluate all of these things, and hopefully we have enough room on your paper to do that. Okay, so g prime of 3, let's start there. G prime of 3, what does g prime of 3 equal? Well, according to our second FTC, g prime is just the function evaluated at that point. G prime of 3 is the same as f of 3. So let's look at our graph. What is f of 3? F of 3 is negative 3. So we have negative 3 times negative 3, right? So this is g prime, and then this is f of 3. Plus g of 3. Well, g is defined as the integral from 0 to 3 of f of t dt. Right? G is defined as an integral. So how do we find the answer of this integral? We look at the area under the curve. Anytime we're evaluating an integral from a picture, we're finding the area under the curve. So from 0 to 3, we have, let's see, what do we have? We have a triangle, 1/2 of base, which is 1 times the height of 4. We have another triangle. Oh, this is the same exact triangle, isn't it? Minus 1/2 base of 1 times the height of 4. Okay, so the blue triangle and the red triangle have areas that will cancel themselves out because the one on the bottom is negative. So we're basically trying to find what is this area here. Well, that's a trapezoid. So 1/2 of 4 plus 3. Right? The height of this trapezoid, the left side of our trapezoid is 4, and the height of our right trapezoid is 3. Actually, these are the bases. Right? These are the parallel sides, so those are the bases, B1 plus B2. And the height is the distance in between your bases, which is 1. So 1/2 of 7 is 3.5. But because it's below the x-axis, remember, it's going to be negative. This is a negative area of negative 3.5. Okay, so that goes in here for g of 3. And now f prime at 3, what's the slope right here when x is 3? The slope is positive 1. Okay, so when we do this multiplication, negative 3 times negative 3 is positive 9. 9 minus 3.5 is 5.5. So p prime of 3 is 5.5, right? So remember what we were trying to find. We're trying to find p prime at 3. P prime at 3 is 5.5. Okay, our next one, part C. The limit as x approaches 2 of g of x over x squared minus 2x. Okay, so remember, g of x is our function. So the limit as x approaches 2 of g of 2 over 2 squared minus 2 times 2. So g of 2 is the integral from 0 to 2 of our function, of our graph. Right? That's how g is defined. And if you remember from a second ago, that was a positive 2 and a negative 2. So the area underneath the curve is 0 from 0 to 2. Okay, that was that blue triangle. Let's look at it. From 0 to 2 is the blue triangle, which has an area of positive 2, plus the red triangle, which has an area of negative 2. So g of 2 is 0. And then on the bottom, 4 minus 4, well, that's also 0. So maybe you remember, this is the indeterminate form of our limits, indeterminate. So we can apply L'Hopital's rule and take the derivatives. So this becomes the limit as x approaches 2 of the derivative of g, which is g prime. Right? If it's a letter, then the derivative is the letter. And what's the derivative of x squared minus 2x? Very good. So remember, from our second fundamental theorem, what is g prime equal to? F of, in this case, because we're going to 2, f of 2. Okay, g prime is equal to f of 2. Over 2 times 2, which is 4. 4 minus 2, we have a denominator of 2. So what is f of 2? The y value from our graph when x equals 2 is negative 4. And then finally, negative 4 divided by 2 is negative 2. And that is our final answer. Okay, so these ones calculus likes to use, right? They love to use this type of notation to see if you know what's going on. G is our integral function, so we have to evaluate it. Well, 0 over 0, L'Hopital's rule, take the derivatives, and then plug everything in that we can. Okay, find the average rate of change, right? This is your clue that we're going to be using the average formula. Average rate of change. Okay, so G average is 1 over 2 minus negative 4 times the integral of negative 4 to 2 of f of t dt. Right, that is our average rate of change formula. Okay, so we're looking at 1 over minus of minuses plus 1/6 times f of 2 minus f of negative 4. No, big F, right? These are big F since they're antiderivatives. So this is the area under the curve from negative 4 to 2. Right? Anytime we're finding an integral, we're finding the area under the curve from negative 4 to 2. So let's go back up to our graph and take a look and see if we can do that. We know this much of our graph is already 0. From 0 to 2, the area here is a positive 2 and a negative 2. So we're basically looking at what is the area of this shape right here. So we can break this into 2 different shapes. We have a triangle and a trapezoid. So let's find the area of our triangle and add it to the area of our trapezoid. So we have a 6 area for our triangle, and we have a 10 area for our trapezoid, which means that this area is 1/6 of 16. And 1/6 of 16 can reduce to, we can divide them both by 2, 8 over 3. So the average rate of change is going to be 8 over 3. Now the second question, does the mean value theorem guarantee on this interval where the derivative is equal to this average rate of change? So things about the mean value theorem. Number 1, it has to be continuous. Is our function continuous? Let f be a continuous function. So yes, it is definitely a continuous function. Okay. Is g differentiable? Can we take the derivative at any one of these points? Remember, the derivative of g is the same as f of x. So is there a y value for every x value? Yes. Okay. So because it's continuous and differentiable, that means the mean value theorem does in fact guarantee a place where f prime is equal to the average rate of change. Okay, moving on. What is the antiderivative of cosine x squared plus 5? X squared minus 5. Dx. Well, let's take a look at our answers. What if we took the derivative of sine x squared minus 5 over 2x? Okay, what is the derivative of sine? Cosine. Well, this one would not be worked like that. This one's going to be a quotient rule, right? Low D high minus high D low over low low kind of thing, because it has a function on top and a function on bottom. So chances are we're going to have a 4x squared. So probably not A. Okay, B, that means we just take this and we multiply it in here, right? If we're going to take this one's derivative. Like, where did it come from? This would give us cosine of x squared minus 5, but also times 2x, right? That's our chain rule. That's the chain rule if we had that one right there. So chances are it's not going to be B. But what if we did this one? What if we plug in this one? That would be the cosine of x squared minus 5. Isn't that what we want? Yeah, that one looks pretty good. I would go with C as the right answer for being the antiderivative. Where did cosine of x squared minus 5 come from? Okay. So remember, it is a chain rule. If anything is other than x, you multiply it by the derivative also. And notice there's no 2x here to multiply by. Okay, our question says, what is the value of f prime of 3? So f is defined as an integral. Okay, so f prime of x is the derivative from 4 to x squared of g of t dt, right? This is our second fundamental theorem. So we plug x squared into here. This is g of x squared times 2x, because you have to multiply it by the antiderivative. Okay, and what is our x value? Our x value is 3. So we want what is g of 3 squared times 2 times 3. So g of 9. G of 9 times 6. What is g of 9? G of 9 is that 4? Would you believe that it's 4?
Yeah. No, I think it's 3. No, yeah, I think it's
4 times 6 is
24.
24. Is that an option?
Yes.
I would go with 24 then and have g of 9 be 4. So that we have an answer that is an option for us right there. Okay, our last one is a nice U substitution problem, which is equivalent if we call this U. So let's do our little U substitution. Okay, our last equation here, notice all this works. So we figured out this was our U, and this is your equation. So we do our U substitution right here, right? And we noticed that x doesn't cancel out when we do our u substitution, which means we have to come back up to your u equation and solve this for x. So x is 1/4 of u plus 3. And then we replace x with 1/4 of u plus 3. And when we do all this math out together, we get this as your final answer, 1/16. 1/4 times 1/4 is 1/16. And then they distribute the u to the 10th into both of those things. Okay, so if your u doesn't cancel, you have to do something else in order to get the integral. Okay, goodbye.